In the previous video, we worked out the first two parts of free response question 5 of the 2012 AP Calculus BC exam. And in this video, we're going to try our hands at part C, which is the final question in the exam. So, question C asks to use the separation of variables to find y equals b of t to find this actual solution to the differential equation. The particular solution to the differential equation with the initial condition b of 0 equals 20. So if we scroll back up to the original question here, we remember that we're talking about a bird who is growing, whose weight is increasing proportionally to the difference between the adult weight and the current weight. So following this differential equation here, db dt equals 1/5 times 100 minus b. And additionally, like the initial condition we just read, at time t equals 0, when the bird is first weighed, its weight is 20 grams. So we can take all of this information. I'm just going to copy this down here also so we can have it. We can take all of this information. Oops, and I think it probably pasted somewhere up here. Here, well, I went and got it separately. The copy function sometimes works kind of oddly. Alright, but we have this here now. So what can we do with it? Well, we say, it says to use the separation of variables to find this y equals b of t. That is a big hint. How might we separate our variables? Well, it's in maybe a little bit of a foreign format here with b's and t's, so if it helps, we can rewrite this as a function as if it were with x's and y's. We could say b equals y, as it's even suggesting up here, and we can say then that t equals x. Maybe this will make it a little bit more familiar. So here then we have dy dx equals 1/5 times 100 minus y. And maybe now it's more clear what we have to do. We should try to get all the y's next to the dy and then multiply out this dx to get 1/5 dx. And once we do that, we get, if we're dividing this 100 minus y, so we get 1 divided by 100 minus y dy equals, and then 1/5, and we're multiplying this dx out now. Well, now that we have this form, separation of variables is complete. Now all we have to do is integrate it. So now we can say that the integral of 1 divided by 100 minus y dy, this is going to equal, I'm just going to take the 1/5 out of the integral here, just the integral of dx. And here, what we can do is just evaluate these integrals. They're not too difficult. So, first off, we have this integral right here. Well, we have a division. This is a big sign that we should be using the natural log. So, in this case, we can say this here is equal to the natural log of the absolute value of 100 minus y. And there's one thing that's important to remember here, which is that if we're trying to take the derivative back to get our original integrand here inside of the integral, we would be using the chain rule, and this negative on the y would multiply out in -1. So this is actually negative natural log of 100 minus y, so that when we took the integral, this negative we're putting here would cancel out the negative from the chain rule from the y. And one more thing here is that we don't actually need this absolute value. Like we discussed up here in the previous problem with the constraints, this will be approaching a horizontal asymptote at b or y equals 100. The bird will never weigh more than 100 grams. Because of that, 100 minus a value that's never larger than 100, that will always be a positive number. So no need to worry about absolute value. We can just write it with regular parentheses. Now, for the right-hand side, we have 1/5, well, the integral of dx is just x. And finally, we have to remember to add c, because algebraic manipulations can affect it in the separation of variables integration. So, now that we have this, it should be fairly straightforward to solve for y equals x. We can multiply everything by -1 to get the natural log of 100 minus y equals negative x divided by 5, and we could say minus c, but that would just be a new arbitrary constant. So I'll call this plus c1, and this here can be plus c2. And then here we can just take e to the power of both sides. We get e to the natural log of 100 minus y is just 100 minus y. And then this is going to equal e to the negative x divided by 5 plus c2. And of course, when you have addition in an exponent, that's the same as multiplication. So we can say this equals c2 times e to the negative x divided by 5. And finally, we can subtract 100. So we get negative y equals c2 times e to the negative x divided by 5 minus 100. And now I'm just going to do it to the right here. This implies the final answer when we multiply everything by -1. This implies that y here equals, well, we're going to get a new constant, but it's still just an arbitrary constant, c3 times e to the negative x divided by 5 minus 100 becomes plus 100. This is our solution. So now you might ask, we have an initial condition here, b of 0 equals 20, and very quickly here we can rewrite this in terms of b and t. So this would become b of t equals c, and we can just write it as arbitrary constant. We don't need the numbers under there anymore. C times e to the negative t divided by 5 plus 100. Of course, we still have this c here. We have an initial condition. Let's use it. So we're given that b of 0 equals 20. b of 0, we also know, however, equals c times e to the negative 0 divided by 5 plus 100. So this means that b of 0, which we know is 20, so 20 b of 0 equals c times, well, negative 0 is just 0 divided by 5, 0 divided by 5, that's 0. E to the 0 is 1, so this entire thing is just going to become c times 1, which is just c, plus 100. That equals 20. Well, this means that c equals negative 80. All right. With this in place, all we have to do is plug in c to get the final answer that b of t equals negative 80 times e to the negative t divided by 5 plus 100. And this is the solution to part C of question 5.